this is pretty good. It'll be okay. It's gonna all come together now in the last section. So that the 2 second sections. Today we're gonna go back to talking about average rates of change, instantaneous rates of change. That whole idea of where we started at the beginning of this limit, and kind of connecting it back to why do we need to do that with calculus. And we're gonna spend a couple days on this. So today and Monday for sure we'll be doing notes over it. We'll probably do problems on Tuesday, Wednesday, Tuesday. But before we jump into that, this kind of is where we stopped yesterday. Explain why the equation e to the x equals x has at least one solution without using a graphic method. What does a solution mean when you solve the equation? What does it find when you say a solution? What x equals what? When you solve like 4x minus 7 equals 0 and you get x equals 7/4, what is that finding? The solution of that equation? When I solve that equation. What does that mean when I find the solution? You've been doing it your whole life, right? What point on the graph? What? Which axis? The x-axis. When you are finding a solution, you're finding a 0, you're finding a root, you're finding the x-intercept. All of those mean the same thing. Like when you do a quadratic, that tells me that it crosses the x-axis. I know it's positive. Even when you solve a linear equation, when you find that solution where it equals 0, you're finding the x when y equals 0, basically is what you're doing. So that's always the x-intercept, the root, the zeros. Alright? So alright, we got that. So you could say, when I ask how do I know this has a solution, another way to say that is, I can subtract x over that's equal to 0. I'm asking for the root. How do I know it crosses the x-axis at least once without having to do the root? And we could actually just solve this, right? Like, what could you do to both sides here? Oh, I don't know. How would you solve that? I don't think we can solve that. Because we could ln this. We just keep, like, I don't know. We would just keep alternating, right? Like, if we tried to solve this up here, we could ln both sides, and that would cancel out. But then to get rid of the ln, you'd have to e both sides, and then you just end up back where you started. So without a graphing calculator, you would, yeah. So that's why it's a good question. Without a graphing calculator, there's no algebraic way of solving it. So I gave you this because what did we end with yesterday? Do you remember that theorem was solved? What's it stand for? Well, in the notes that you had in your binder somewhere. Intermediate value theorem. What does it say again? Right. If the function is continuous. So here's the question. Is e to the x equals x, or we can say e to the x minus x equals 0, is that a continuous function? Domain, yes. When we talk about continuous, we're talking about domain. So, can you plug anything you want in for x in an exponential problem? I don't know what this looks like with the minus x, but e to the x, remember, kind of looks like this. It does have a domain of all real numbers. Minus x is not going to look just like that, but it's still, x could be anything. So by looking at this, even though I don't know how to solve it, and I don't know how to get the answer other than graphing it and finding it, I could say I know for sure there's one solution, because e to the x minus x equals 0 is a continuous function, or you could say it has a domain of all real numbers. Okay, well, how does that help? Well, then I was just thinking, does it really cross the x-axis? Remember the one I used yesterday, how like I said the same sign, like we were sure like my graph I drew here, does that cross the x-axis? So how do I know it crosses the x-axis? A good way to start class, right? No, but we're not supposed to graph it. We're supposed to use the intermediate method. So we're... Oh, yes. That's what's supposed to happen. Oh, you know why that it doesn't have a solution? I'm pretty sure this one doesn't have a solution. Because I broke the equation wrong, which is why I'm struggling so much. Because I'm like, this is not right. This is like how this is supposed to happen. I normally give this question on the homework out of textbook. I did not have this homework on my part, so I thought it was Here's the question. So this question does not have a solution because of this e to the positive x. Like it does never touch the x-axis, so it does never equal 0. But the real question was supposed to say e to the negative x. Yeah, what happens when we plug, if I have e to the negative x minus x, instead of putting equals 0 now, what if I just make that a function? That's really what happens. When you set it equal to 0, you're just making y equals 0. Remember zeroing off that algebra. What happens when I plug 0 into this problem? If I did f of 0, I would get e to the 0 minus 0, right? Which is 1 minus 0, which is 1. So far, so good? Do you think those 0 powers 1? What if I plug 1? To the negative 1 minus 1. That's just 1 over e minus 1. Is that going to be a negative number or a positive number without a calculator? Do you know? Because, do you know what e is as a decimal? So if I flip it over, 1 over 2.71, like that's going to be smaller than 1. So when I subtract 1, I don't care what the decimal is, but I know that that's going to be less than 0. So this is why I was stumped on this question, because I was like, this is always positive, I don't know how to do it. So by saying this, I know it's continuous. So if I know at f of 0 it equals 1, and at f of 1 it equals some negative number, do I know it had to cross the x-axis at some point? Yeah, that was a long way to get there. But I shouldn't say it. You shouldn't use pronouns when you're writing your math answers, because on the AP test it's it. Don't use this in the graph. You have to name it. What are you talking about? A function. Because f of x is continuous, and f of 0 is greater than 0, while f of 1 is less than 0, by the intermediate value theorem, there has to be a solution, or a 0, or you could say there has to be some point where f of x is 0. Sorry about my wrong typing. My first example, there was no solution, and we could also prove that we don't know there's a solution, because I think if we just maybe not, maybe even I just wanted to give you a problem where I was actually using it. Now I just mission failed. I'm very stressed already about the trick review rate, because I always give a calculus test over grade rate, and I'm very stressed about it. If I just so get a feeling that you can learn calculus. I always do, and then I always do it. But I'm going to, which makes me feel stressed about doing this. Because we're leaving on Thursday during school and not coming home until Sunday, and have to come back to school on Monday. And normally I'd say, you have time, like you're going to have time to do it. I think it's early as you get wait a minute. It's like, oh, I don't think we're going to have signals at the time. I already told Madison, don't play with your phone. Sit there. The Wi-Fi. Okay. All right, let's do some real calculus. Average rate of change, hopefully you associate that word with, don't read that, average rate of change, slope, right? Slope is rate of change. So we can talk about the average rate of change of a function over an interval is the amount of change divided by the length of the interval. If you have an interval from A to B, right, that's your interval, and you wanted to find the rate of change, you take the y values over the x values, which is slope. It's just slope. You could take f of b minus f of a over b minus a. We're going to talk about the idea of how we can look at the slope, and instead of just looking at the slope of a linear line, we can draw a secant line to a curve and think about the slope of that secant line. So, like if I had, and I'll go in a minute on the next page, but if I had a curve here, and I picked 2 points on that curve, and drew the line through them, I could find the slope of that line. And a secant line in geometry you define as a line that goes through a circle in 2 points. But it's really a line that goes through any curve in 2 points. And so if you found the slope of those 2 points, we would say that that is the slope of the secant line to the curve. It's also just the average rate of change from a So you've done this already, except for in the first section we called it average speed or average velocity, which is the average rate of change. These are all interchangeable orders. You're going to find that in calculus we have about 10 ways to ask the same question, and you have to just know that all of these do the same thing. So when I say find the average rate of change for this curve, which is a parabola, from -2 to 4. So just from -2 to 4, I can find the slope of that secant line that I could draw through there. I don't really have to draw it because this is my A and this is my B. So I can find my average rate of change by just taking the slope of the Y value subtracted divided by the X value subtracted. F of B minus F of A of B minus A. And then you would just plug it in. I'm going to do this without a calculator. 4 times 4 squared is 16 times 2 is 32 minus 12 plus 7. Bunch of negatives here. Minus, I'm going to do parentheses. If I plug in -2, I'm going to get 4 times 2, which is 8 plus 6 plus 7. And I don't really... You don't really have to do it without a calculator all the time, but I'm going to do right. 32 minus 12 plus 7 minus 8 minus 6 minus 7 all over 6. So that's going to cancel out, and that's going to be -26. So 32 minus 26 is 6. You done this math yet? It's just sitting there taking it all in. 20 minus 8 is 12. 12 minus 6. I'm going with my answer of 6. Reputation to uphold with my calculus scores. I think it's a lot of 30. Right, so that means if we graph this quadratic and we look from -2 to 4 and we drew in the secant line, that the slope of that line would be 1. What do we care about that? Well, we care about this because just like we can find average speed, average velocity, we want to also be able to find instantaneous speed, instantaneous velocity, which means that we want to be able to find the rate of change at a specific point on the graph, not any points. So we're going to talk about a tangent line as opposed to a secant line. So in a circle, do you remember the definition of a tangent line? Yeah, a line perpendicular to the radius, which means it only touches in one point. So you have your circle, and then like you have a point over here, and like you draw your line. That's a tangent line. It just touches the curve in one point. For us, we can draw that in on any graph. And it really can touch in more than one point, but like the point that you call the point of tangency, that's what we're looking for. We want to find the slope of the tangent line of a curve at a specific point. So let's draw a curve. So I'm just going to draw like this. And I'm going to pick some point here. So we're going to call that point. And just like we talked about on the very beginning of this chapter with that instantaneous speed, we can't find the speed at a specific point, but what we can do is pick 2 points really close to it, and the closer we move those points together, the closer that it gets to being that exact point. And we're going to use that idea when we find the slope of a curve. So if I had, I don't know if you want to draw this on your paper because it's going to be much harder for you to imagine putting it together. But like if you had a point out here where this was, let's do the point over here, and we'll call this C plus H. Right? Remember the plus H on this? If I connected those two, it would be what we just did on problem 1. We could find the average rate of change using the secant line. But if I moved it even a little bit closer, right, if I made H even smaller, I could then connect that and look to see what the average rate of change was. And theoretically, if I just keep moving it closer and closer and closer and closer, as H goes to 0, it becomes 1 point instead of 2 points. That's that whole idea of a limit. So, I don't really know how to write that there, but we want to take the limit as H approaches 0 of the average rate of change, and it will give us the slope of the tangent line to just 1 point as opposed to 2 points. And to find it, we're just going to do the average rate of change between C and the y value that would go with C would be f of C. And the y value that would go with C plus H would just be f of C plus H. And that first day that we did this stuff in here, should kind of jog your memory, we can say this is just saying like the slope of the secant line equals the change in y's over the change in x. I don't know if you want to write that or not, but the actual secant line would just be f of, you want me to use the C, I'll just use C plus H minus f of C all over C plus H minus C. I could have used x's there, but I'm just sticking with my same letter I used over there. But do you remember at the beginning, at the bottom, where the C's always cancel out? That's the secant line. If we want to find the slope of the tangent line, we're going to do the exact same thing, only we're just going to take the limit as H approaches 0 of f of C plus H minus f of C. And I'm going to go ahead and just say all over H because you can see that the C's cancel out. And no longer do you have to make a table and approximate. You can just use what we've been learning about limits and say, if it says find the slope of the tangent line, or find the instantaneous rate of change at a specific point, I only give you 1 point, then you can do the limit of that. Questions on that? Sounds like a big old definition, but I feel like I'm right. You're gonna, yes, you're gonna remember this because you're gonna use them on every homework problem between so do all your homework, but yes, you need to know this, and I think we're gonna write about 12. I may be. So finding the slope of a curve at a point is kind of this big idea that we're going to spend forever talking about. And these all mean the same thing. Notice I use C, they use A, instead of X equals C, X equals A. But if the question says, find the slope of a function at a specific point, that means do the limit of the secant. If it says, find the slope of a tangent to the equation, they just call it slope of a curve, they just call it slope of the tangent. at a specific point, an interval point. If you see that word instantaneous rate of change, and Monday we'll talk about, we could say instantaneous speed or velocity. Again, instantaneous means at exactly one point, not average. You're going to do the same thing. And sometimes the question just says do this, which means find the slope of the curve. Like this is what you have to memorize. And it just says it's the difference quotient of f as a, that slope of the theta. So right now, this is really all we know how to do besides average. The big mistake that people make on the test is I give you one that's like number 1 that says find the average rate of change. That's just slope. And people do the limit because they are just so used to doing it. But there's a pretty good chance right now that the questions on the next couple days homework, you're going to be doing this quotient here for that. So let's see if we can at least get through one. So find the slope of the curve at x equals a for the equation y equals 9 minus x. So when we see this, we're going to do the limit as h approaches 0, f of a plus h minus f of a. And again, we're just subtracting a plus h minus a, but I just always put h there because I know that the a's always cancel out. But if you want to write out subtracting the x's, you can. I went ahead and put a in there since it said a. If it said x equals 7, you could plug 7 in there, and you're going to get an actual number answer. So now we get to practice our function notation. If I want to do f of a plus h, that means everywhere there's an x in this problem, I'm going to replace it with a plus h. So I'm going to get the limit as h approaches 0 of 9 minus a plus h squared minus just f of a, which means everywhere there's an x, I'm going to replace with an a. And again, watch your negative sign. I'm going to put parentheses 9 minus a squared, or if you want to go ahead and distribute that. Your sister never, she always puts her negatives, always. Every time. She would make this minus 9, but she would leave that minus a squared, and she would always miss questions because she didn't distribute her negatives. Every single time. That's the kind of word she got from the year for never distributing negatives. Because she always makes mistakes. So, I don't care which way you do it. I kind of get in the habit of I just change the signs as I go. Like if this was my homework paper, I would have written minus 9 plus a squared. But it's however, like whatever makes you more comfortable to do. Also, remember that you're foiling that out. So I would have 9, and I'm going to FOIL and distribute the negative at the same time. So that'd really be a squared, but it's minus a squared. It would be plus 2ah, because the negative in front makes it minus 2ah. And then plus h squared, just minus a squared, so that should be negative. Just FOILing that, it should have all been positive, but that negative sign in front makes it all negative. And then I get minus 9 plus a squared over h. Remember, when we did this at the beginning, and we talked about this algebraic way to find the limit, what should happen is everything without an h at the top should cancel out. So it's really nice that that should happen if there is a value there. So if it doesn't, if for some reason you left this minus a squared, when you see that it doesn't cancel out, hopefully that tells you to go back and switch your signs. But that's going to cancel. Positive 9 minus 9 is going to cancel. So, again, I'm trying to get to the point that I can take the limit here, and I would get, what do I have left on top of this? So I'm going to factor out an h. You might say, well, why don't you factor out a negative h? You could. But I'm just trying to get the h's to cancel, so I'm going to leave that as negative 2a minus h all over h. Anyone have a question on where I got that from? All of that is the algebra to get to the point I want to take the limit when h approaches 0. So now, if I cross these h's out, do you agree I can just do direct substitution? And I would just get negative 2a minus 0, which means I just get negative 2a. I get an a in my answer because the original problem was x equals a. This is kind of a really important concept that we're not there yet, but this is the slope of any tangent of this curve. So you could pick any point now, and I could say, well, what about when a is 7, or x is 7? You could plug 7 in there and say the slope is negative 14. What about when a is negative 1? The slope is positive 2. So if you leave it as a variable, you get this equation that you could find the slope at any point on that curve. And so that's why they start out like that. It's a big, big deal. Oh yeah, a big deal. Big. I appreciate the hugeness. It says, at what point is the tangent to this function horizontal? So we're talking about tangent lines. That's sort of horizontal. What's the slope of a horizontal line? 0. So this is not saying find the slope at the point 0. It's saying when is the slope going to equal 0? So remember, oh my gosh, there's a paper. What we're finding is the slope of the tangent line. So when we do the limit as h approaches 0 of f of, what are we using a? Use x. Use c. Just equals a. Use x. Use x. Use x. Well, what did you say? Okay. Well, I don't know what you said. Okay, I'll just, I don't know what to do. Okay. I want to use x, but the book used a and use x. This is our equation for the slope of the tangent line. So if we want the slope of the tangent line to equal 0, we want this to be equal to 0. So you have to interpret those questions about what am I doing? Am I plugging 0 in, or am I setting it equal to 0? Oh, look at this one. This is a lot of algebra. We might not get through this. We might have to just watch the Boolean video and stuff. A plus h means I have to plug a plus h in here and in here, right? So I would get the limit as h approaches 0 of 3 minus 4 times a plus h minus a plus h squared. And then I have to subtract plugging a in there. So I'm going to distribute my negative this time. So I'm going to say minus 3 plus 4a plus xa squared. You with me on that? I just distributed my negative in there. Now I do a lot of algebra. I want this to equal 0 at some point. So, I'm really bad at rewriting limits every time. I'm going to try to do it. I'm going to get 3 minus 4a minus 4h. Someone don't have it to do. Sticks and through. I scanned it, but I haven't seen it. Oh, and just so you know, to do with the science of your series, that would That just killed me. No, she's gonna cry more. Don't. I told her you were scary too. I agree. Okay, goodbye. I have 2 seconds. For 6 straight. I FOIL and distributed by negative minus 3 plus 4a plus a squared. That's fine. What's your question, Christy? It's a lot, right? So like I always do what Lois just said. I just start marking things out because anything without an h should cancel out. So I have a plus a squared, I have a minus a squared. I have a minus 3, I have a plus 3. I have a minus 4a, I have a plus 4a. And if you have something left that doesn't have an h in it, you should go back and check your math. And then I always go ahead and factor that h out. So on the top, I'm going to go ahead and factor the h out, and I'm left with negative 4 minus 2a minus h. And again, I want this to be equal to 0 at some point. I'm going to remind myself of that. So I'm taking the limit on this side. So I cross those h's out, and when I plug 0 in for h, what's left with h? Do I just get negative 4 minus 2a? Because the other h is just 0. Crossed out the other h's. That would be my equation for the slope of the tangent. I want that slope to be horizontal, which means if I get to this point, now I can set it equal to 0, and I can actually solve for where on that curve would it have a horizontal tangent on, especially Christy, what's your question? I plugged in 0, so I did direct substitution. So I have negative 4 minus 2a minus 0. That's okay. That's good. Yep. That's why I ask. Don't ask questions so I can tell you that's what it is. I would everyone try to tell me. Other questions? So because this doesn't say find the slope at this point, it says find when the slope is 0. I can solve this for a. So I'll get negative 2a equals 4. A equals negative 2. When we talk about a point on a graph, do we normally just have one number? And we normally have a point, right? And so I know on your homework, it's okay if you don't get to all of it this weekend because we'll do it more Monday. But I know there's a question either on day 1 or day 2 that asks you this exact thing. And if you just wrote negative 2, you're going to get it wrong because they want to know where, which means you have to find the y that goes with that. So the a, the x, we know that that's at negative 2. Is it negative 2 or positive? Negative 2. You have to find the y value that goes with it. Like, what's the y value when x is negative 2 to find the point on that graph? So I'm just plugging it in. I get 3 plus 8 minus 4. 7, is that true? Yeah, that's right. 8, 11 minus 4 is 7. So at what point does it have a horizontal tangent? At the point negative 2, 7, it would have a horizontal tangent. So I promise we're going to spend a lot more time. This is our last section. I do have more notes on Monday. But then that Monday is last day. Notes. That's until Thursday. Tuesday, like a question day, practice more problem day, to do that, and I promise that it gets better. In chapter 3, we pick right back up where we left off here and define this in another way with psychological pages. And all of chapter 3 is all about how to do this. Okay. So there is homework on Math Excel. There's actually 2 days of work on Math Excel. It really works when you want to go ahead and look at both days. But try at least some of them so that you can come in with some questions and you can talk about some stuff on Monday. You can do more of the same stuff on Monday with a little bit extra, and then tests next week. I put a couple videos on my maybe with my buddy Patrick, including the bullying video that I didn't show you. Don't tell me.